Hi, this is Mr. Brown from A-Flight. I know what you were thinking. You were sitting there saying, gee, just if somebody would explain to me what this 60 to 1 rule is. Well, you're in luck. That's what we're going to cover today, the 60 to 1 rule. Now, when we talk about the 60 to 1 rule, there's a lot of different uses for it, and there's a lot of background to it. You see, most of what we do in aviation actually comes from the days of sailing ships, the Greeks and the Phoenicians, and everybody since then. They had to develop a way to navigate around the seas back then. A lot of people tend to think that Christopher Columbus thought that the world was flat. He's the first one that proved it's round. And that's not true. The Greeks themselves were the first ones to sit down and calculate the diameter of the Earth. And for all intent and purposes, they were actually pretty close. So from that, with the Greeks, and since that point, they realized that in order to navigate on the seas, they needed to use a different measure for distance than what they used on land. Now, let's face it, the Greeks did not do things in feet, miles, kilometers, or even meters, okay? Whatever units they used is what they used. But they realized that they needed something out on the ocean. So what they did, they said, well, a circle, they had figured that out, is 360 degrees. Each degree can be broken down into 60 minutes. So they established a nautical measure of distance equal to 1 minute of latitude. And that's 1 minute of latitude at the equator. Now, a couple hundred years ago, they did the math with that, and it came out to be approximately 6,080 feet. And they said, that is going to be a nautical mile. Well, nowadays, we've actually refined that. A nautical mile is 6,076 feet. So a couple hundred years ago, they were pretty close in that measurement. So that's how we define a nautical mile, 6,076 feet if you're using the imperial method of measurement. I don't know how many meters or kilometers that is. But that is, once again, it comes from 1 minute of latitude. Okay, so 1/60th of a degree of latitude is a nautical mile. So what we can do with that by using that, now in the airplane, we tend to round that down to 6,000 feet because it makes things a lot easier. Okay, in our mental math, we use 6,000. So we come up with something called the 60 to 1 rule. Let's say I have a nav aid here. If I go out 60 nautical miles, then if I take a segment of that circle, a small arc here, equal to 1 degree, how far will I move? Okay, what is that opposite length of my triangle? So here's how we figure that out, and this is how we come to our 60 to 1 rule. We know that the circumference of a circle is 2 pi r. So that's going to be 2 times 3.14. I'm not going to go fancy and math teacher on you and take it out to any digits greater than that because we don't need to for what we're doing, times my radius, which is 60 nautical miles. So I've got my calculator here. So 2 times 3.14 times 60. Let's see here. I think I did something wrong. Hold on a second. Clear. 2 times 3.14 times 60. Okay, so I do that, and I get 376.8 nautical miles. That is for a full circle. But there are 360 degrees in a circle, and I want 1 degree. So if we take 376.8 and divide by 360, we get 1.046. Let's call it 1.05 nautical miles. For all intent and purposes, then, what this is saying is if I go 60 miles out, I change by 1 degree, I will have gone approximately 1 nautical mile. So 1 nautical mile for every 60 nautical miles. So there you go, 60 to 1. Now, the reason this is so important is, well, so many things we do. For example, calculating a descent gradient. So if I redraw this and I say, all right, here's 1 degree, here's 60 nautical miles, here is 1 nautical mile. Well, we said 1 nautical mile is, let's keep it simple here, 6,000 feet. So if I divide by 60, that tells me that 1 degree of pitch change, I will change my altitude by 100 feet for every 1 nautical mile. And that is what we use as we calculate our descent gradients. A lot of times that's what we use calculating our turn radiuses as well, trying to intercept an arc. So if I am, for example, my threshold crossing height of 50 feet, trying to figure out where this would be then. It's on a 3-degree glide path. Well, 60 to 1 rule says that this is 3 degrees. Then for every nautical mile, or 6,000 feet, I will change by 300 feet. Well, I want this to be 50, so I divide by 6. And what that tells me is threshold crossing height of 50 feet and a 3-degree glide path, my aim point is 1,000 feet down the runway. I talk about that in my lesson on aim point and transition to landing. We use this a lot calculating our descents on final. If I know that I am doing 110 knots, that is approximately 120, which is 2 nautical miles per minute. If I lower my nose 3 degrees times 100, I should have a 600 foot per minute descent rate. And again, that uses part of that 60 to 1 rule. Also, 60 to 1 rule, other things that tells me then is that at 60 miles, there are 1 radial per mile. If I'm at 30 DME, there are 2 radials per mile. If I'm at 20, there's 3 radials per mile. 15, there's 4. 10, there's 6. Okay. So those things need to multiply up to be 60. 60 times 1 is 60. 30 times 2 is 60. 20 times 3 is 60. 60. 60. Okay, so that even is derived from our 60 to 1 rule. So that's what the 60 to 1 rule is. It's all based off of the fact that a circle is 360 degrees and our nautical mile is 6,000 feet. 36 divided by 6 goes in there very, very nice, very evenly. So a little geometry, a little history, and we come up with our 60 to 1 rule. I'm Mr. Brown, down at A-Flight. Happy flying.